Right, so in this introductory session, we are going to learn about project planning. The plan in the first half of this session is to learn about project drawing project network diagrams and critical path method, and how do we go about critical path method calculations. We will also review some of the fundamentals of project management. We will learn how do we transfer the network diagrams into Gantt charts or bar charts. And thirdly, we will have a brief overview of different project planning methods. So in the first few weeks, we will be focusing on acquiring some practical skills and demonstrations so that we understand that how do we practically plan a project, whether it's a small scale or a large scale project. So we will start firstly by drawing a network diagram or a precedence diagram, and it basically helps us understand the logic of different or a sequence of different activities taking place. Then we will learn to forward pass and the backward pass. This helps us calculate the early and late time for various activities. So basically, early time is how soon you can begin work on any activity, and the late time is how much delay you could do any activity without causing the project to be delayed. Thirdly, we will review how do we transfer this network diagram and these calculations into bar charts. So you might have seen Gantt charts or bar charts hanging on construction sites. So it's a very popular communication tool. And next, we will how we could populate these bar charts with resources. So not only using it for the time planning, but also loading resources to it. So resources could involve things like equipment or workers. So how do we produce a resource loaded bar charts? And lastly, we will look into how do we use the same tool for our cost planning and monitoring. Right, so here planning is one aspect, that but then it's very important to ensure that we have got monitoring and control arrangements, because plan is a live document. You would review it on a almost on a daily or a weekly basis, and when things are not going according to the plan, the strategy would be to introduce some monitoring and control arrangements. So we will start by a bit of a overview. Now, I will just like to bring to your attention this famous quotation from Confucius, which states, "I hear and I forget, I see and I remember, and I do and I understand." So in the teaching approach, there is a particular emphasis for students to try to practice various problems. So maybe during this session or maybe afterwards, you could practice it. Maybe you are an experienced professional, so this may serve as a refresher for you. But if you're doing the planning for the first time, you may like to do it practice, because a lot of literature indicate that we tend to understand and learn more what we say and do rather than you just listening. There's a high probability that you are going to forget and that, but if you get a chance to apply those concepts, then you would tend to remember. So we will be doing a lot of different case studies, talking about different project management scenarios, and always you can keep your pen and paper and try those. Right, so how would you define project management? There are a number of different definitions. One of my favorite one is that it is an application of tools and techniques that enable us to deliver project on time, cost, quality, and safety targets. Now, this is just one view. There are a lot of different definitions of the project management, different books. And you may like to have your own definition which suits your project. I like it for the reason that the key emphasis is that the focus is on application of tools and techniques that would help you deliver, and this suits the way this module will be delivered very much, because we will be learning how to apply various tools and techniques that would help us to stay on schedule and to ensure that our project is meeting its time and cost and targets. Now, uh, different authors, different view of project management. Few of them, they perceive project management as more of an art on the soft side, which involves having effective communication skills, trust, integrity, honesty, sociability, leadership, values, staff development, flexibility, decision making. To a certain extent, we can say that it's a bit of a politician's job, keeping everyone on track, communicating with everyone, keeping everyone happy, integrating them. So it involves a lot of soft skills, things like negotiations, customer relations, problem-solving skills, managing change, and managing expectations. So there is a soft side of project management, but then there is a scientific side of it, or a bit more mathematical or quantitative driven things like plans, like network diagrams, critical path methods, work breakdown structures, Gantt charts, standards, critical path method, precedence diagrams, controls, variance analysis, matrix methods, earned value, which is used for monitoring, or S curves, which is used for reporting progress of a project, risk management, status reporting, meeting agendas, resource estimating, leveling, training, mentoring, and consulting. And we are seeing in recent years more and more scientific aspects becoming more important in project management, right? So it is important to recognize that the project management is essentially a combination of science and an art. And it's very important for us as individual project managers to reflect on our own capabilities. And sometimes perhaps we are very good at science and not so good in art. So perhaps it will be good to have a team where the art aspect is also being covered, or if vice versa, if we are more art person, then it will be good to have a balanced approach so that we have the right team members on board to address various sort of situations we would encounter. Now, when we talk about effective project and production management, our goal is usually to hit the top right quadrant here. So to have projects which are firstly properly planned and then properly executed. So putting it in this way, projects which are designed to build and then they are built according to the design. So we are seeing a great deal of a push these days towards modern day technologies such as BIM, which allow us to visualize our project and plan it so that and add more details to support the production. So we are designing so that it could be taken and used for production, and then when we go on site using different tools, we try to ensure that it is being built according to what was designed. Right. So as I said, the goal is to hit this top right quadrant, but it's easier said than done. If we review a lot of projects, end up in a situation where there are flaws in the planning and flaws in the execution, or sometimes planners and designers did a good job, but the contractors and the production team messed it up, or the other way around, where there was a problems in planning but good in execution. Right. So when we talk about construction projects, it's not a very simple project. Our production mechanisms are quite complex. There is a great deal of stakeholders, for instance, owner organizations, owners, facility managers. So if we are talking maybe of a hospital construction, we may have to deal with a large public sector client like us, which would have its own hierarchy, then design or engineering organization, which would include architects, structural engineers, building organizations, including schedulers, estimators, subcontractor organizations, and then the outside organizations, government agencies, community insurers, end users. So it's very sometimes difficult to integrate all of these multiple stakeholders to ensure that we end up with a project which was properly planned, properly executed, which was designed to build and built to the design. Right, so a reflective question here, what is the difference between planning and scheduling? Now I'm flicking through the slides to ensure we cover the content in a given time and slot. If you're watching the video at a later date, you can just pause it at this point and compare your answer with the suggestion here. So it is very important to recognize there's a difference. Very often these terms are used interchangeably, but planning is slightly a broader concept when compared to scheduling. Scheduling is seen as a subset of planning effort. Planning helps answer questions such as what is going to be done, how, where, by whom, when. So big strategic questions, and then we have got all sorts of plans, including financial plan, environmental plan, sustainability plan. Whereas scheduling is a bit of a subset of planning, which involves determination of the time and sequence of operations in the project and their assembly to give the overall completion time. So if we could visualize it, the planning effort would be the whole pie here, which would include answering questions like what, when, how, why, where, by whom, who, how much, whereas the scheduling effort is a subset of it. But the impact of scheduling is that it in a way influences the planning effort. It involves capturing a lot of data from and the entire planning team. It involves understanding the logic of how the project will be delivered, and in a way it positively influences the entire planning process, right? So let's see what are the key steps involved in planning a project. So whether it's a simple project or whether it's a mega project such as the London 2012 Olympics, I'm taking an example here of the key work packages involved. All the projects start by defining what are your key tasks and putting them in a logical order. So here you could see the listing. So basically determination of what are the key tasks involved and how long each task would take. So we start by describing our key activities and estimating duration. So for instance, we want to take a very simple example, maybe getting to work at 9 o'clock. So in this example, my target is to get to work at 9 a.m. So I want to be at work. So if we want to maybe schedule this, perhaps we can say that, well, at 7 a.m. Should be my wake up time. From 7 to 7:20, maybe shower. From 7:20 to 40, maybe we could do two activities simultaneously, maybe breakfast and maybe dress up for the day, and maybe at 8 o'clock we could grab a bus and off we go. So very similar to the previous example, we determined what are the key activities. Once we have done it, then we need to put them in a logical order. So let's assume I call these activities names. So A, B, C, D, E, and F. Using activity of network, A would be a milestone activity, right? So I need to wake up before to do anything, and then this is followed by activity B. Then after B, we're doing two activities simultaneously, which involves activity C and D. And once we have done that, then it is activity E and F. Now this basically indicate the logic of how I would achieve my very small accomplishment of getting to the work at sharp 9 a.m. Right. So when we talk about estimating our project activity durations, time and resource estimates should be made by those most familiar with the task. Estimates should be based on the normal conditions. So right, so we could have an optimal time or a pessimistic time. So usually we base it on normal conditions. Time units and price should be consistent. Work task estimates should be treated as independent estimates and not influenced by other project tasks. Contingencies should not be built into estimates at this stage. Top management will have a contingency plan to use if necessary, so we would be planning without contingency. And remember, these are estimates, and errors and mistakes should be allowed and not punished. Now we will come to it, but sometimes the schedules are used as to promote some sort of like a toxic culture and blaming each other. That should not be the purpose. It should be to promote good teamwork and to know who is doing what in which order. Right. So once we have determined what are the key activities, then it is important to put it in a logical order. So here you can see this simple construction of a pyramid. And now there is a certain logic to it. So, for instance, you cannot lay your block 2 unless block 4 and 5 are in place. And likewise, block 3 cannot be put in place unless you have got block 5 and 6 in its place. And likewise, 1 cannot go in its place unless you have got 3. So if you have to draw a logic diagram, a network diagram, we could start. So very often we could have a milestone activity as a project start. Now, and the activity block 4, 5, and 6, they are pretty much independent of each other and could be done in any order. So I could put 4, 5, and 6 because there is no logical dependence. But 2, there is it can be done only once 4 and 5 are in its place. So we define this relationship, which is called finish to start, indicating that we could only do 2 once 4 and 5 have been done. And likewise for 3, if you can't do late block 3 unless block 5 and 6 are in their place. And the last activity is 1, which would require completion of activity 2, 3, right? So this would indicate the logic of how this project will be delivered. So while defining the logical relationship, we have to understand which activities must be complete before this activity starts, which activity cannot until this activity is completed, which activities have no logical relationship with this activity and can take place at the same time. So some of the conventions that we have to keep in mind before an activity may begin: all preceding activities must be completed. Arrows imply logical precedence only. Length and direction is not significant. Event numbers must not be duplicated, and any 2 events may be directly connected by 1 activity. So and networks can only have 1 start and 1 end event. So we will do a few small examples to put these ideas into practice. So very often we would start with a method statement, which would be based on our interviews with the people who have to do the production. So they will give us a briefing that this is how the project will be undertaken, and then we convert it into a network or a logic diagram. So if we read through this method statement of a construction of a block of apartments, the contractors are telling us basically that site must first be cleared. We can see that this is the first activity, and prepare for construction. Once the site is ready, the utilities services can be installed. So there is a finish to start. So once we have cleared the site, then we can start utility services and connect it to the existing city main lines. The foundation of the apartment building can then be formed and poured. So the third activity is foundation, which is depending. So we could start building our network diagram, which would be something like, first of all, clear your site. Once you have cleared your site, then second would be install your utilities. And once you have done that, then you can start building your foundation, right? So we have sort of a done example here. So we were reading through here, the foundation of the apartment building then can be formed in 4 chords. So here you can see all the relationships are finished to start, which essentially means that the preceding activity must finish before subsequent activities will start. So you have to finish installing the utilities before you will lay the foundation. However, as we continue reading the problem description, it states that after a 10-day period for the foundation to gain strength, work can begin erecting the superstructure. So basically, um, and after the foundation, we have to wait till the for 10 days the foundation or concrete to gain strength, and then we could begin work on superstructure. So mind you, this is a relationship of a finish to start with a lag of 10 days. Now, the following statement reads, work on the exterior of the building can follow 2 floors after the superstructure starts, which is roughly 5 days. So basically, what the keyword here is that we do not have to wait for the superstructure to finish, because that would add extra delay. And so we have to just wait for 5 days since the superstructure starts, and then we can start working on the exterior. So mind you, the arrow is coming from here now, that we don't have to wait for this activity to finish. Rather, as soon as we are starting at arrow from the start of superstructure activity, leaving a time lag of 5 days, and then we are beginning work on the exterior. Work can begin interior 1 floor after the work on the exterior starts, which should be another 5 days. So the exterior again has got a start to start relation with the activity exterior with a lag of 5 days. And then finally, cleanup of the site can begin after all the work is finished. So cleaning up is the last activity. So here we saw different types of relation between activities. The most common one was finish start. Also, we saw start to start and then finish to start with some lag. Now, the benefit of start to start is that it allows for 2 activities to take place concurrently. So we do not have to wait for the entire superstructure to finish, which could be a long activity. Rather, we could leave a time lag of 5 days and could begin work on exterior concurrently. This was saving some time project. So very often when we try to save time on our project, we look into the logical relationship. We see the relation, is it finish to start, and is there any scope to change that finish to start to maybe a start to start, maybe with some lag, which may allow us to save some time from our project. So as we plan our projects, the key planning considerations are what should be done, what are the key activities, how those activities would be performed, what are the key methods, who should perform each activity, and with what means, what are the resources, when should these activities be performed, what should be the sequence and the timing. Right, so we continue doing a little bit of more practice on drawing a network diagram, because this is a very fundamental. So here in this example, you can see the first activity is A. So we start with A. Now, the predecessor column is telling you that B has a predecessor A. So B can only take place once A is finished. C has a predecessor A, which basically means that C will also depend on A. And then D has a predecessor B, so D is taking place after B, and E has a predecessor B and C, so E is dependent on B and C, and F depends on F is taking place after D, and G G is an activity which is depending on activity E and F. So using such predecessor relationships, we will complete the network logic diagram. So a bit of a theory of a network diagram. As the project becomes larger and more complex, the Gantt charts were found to be lacking as a planning and control tool. Although bar charts does show logical relationship, and became cluttered as the number of activities and logical relationship increase. Feedback from the industry and commerce in 1950s indicated that there is a need to develop scheduling methods which integrated project procurement, resources, and cost. And this led to development in the form of a PERT, or program evaluation and review technique, and critical path. We will be reviewing on both of these techniques. The format of the network diagram presented activities in boxes, and the sequence of activities from left to right shows the logic of the project, right? So we learned how to draw a network diagram. Very often we draw a network diagram at a strategic level, and then this could be, for instance, a project on its own, where we could be talking about different blocks within the entire site. And network diagram gives us a bit of an understanding of the overall uh, logical sequence. All right, so while doing previous examples, we did talk about two relations. One is finish to start and start to start, but there are four relations in total, including finish to finish and start to finish. But I must say, two top ones are the most common ones. So finish to start is the most common type of dependency. The successor task cannot start until the predecessor task is finished. Example of a finish to start relationship could include things like you must write your coursework before I can assess it. So my assessment is based on you completing your job, just completing the coursework and then handing it over. Or you must buy a computer before you can install a software on this computer. Once you have submitted the coursework, there will be a time lag of 14 days prior to the result announced. Okay, these are a few examples. And the start to start, the successor cannot start until the predecessor starts. And as soon as you start getting the bricks on the site, you can start the work. So you do not need to wait for the entire activity to be finished. You can start. So here, this is an example of a start to start, and this is an example of a start to start with a lag. Right. So we will now start looking into TM calculations as well, and how do we manually schedule a project. So here you can see a network diagram indicating different types of relations. So here is an example of a finish to start relation with a lag of 5 days, and here is an example of a start to start relation with a lag of 3 days. So we will learn how to perform CPM calculations. Now, when we are manually scheduling a project, we assume that the project starts from day zero. But if you are using a software tool like Microsoft Project or Asta Project or Primavera, you can specify the date, or by default, usually the projects will assume that the project is starting the day to day, the calendar day to day. Right. So here in this example, this indicates duration. So for activity A, the duration is 2. So if we are starting on day 0, we have to add this duration. So this would be. So this box over here basically tells us the early start time, and this box tells us the early finish time. So this is the earliest possible time, which is day 0 of my project, when I could start on activity in A, and in 2 indicates early finish time. So what do you reckon should be the early start for activity B? The duration is 4. So I'm completing this activity on day 2 of my project. There is a lag of 5 days involved. So thank you, and that should be 7. So 2 adds 5, 7. So basically, we are finishing this activity by end of day 2, and then we are adding 5 and 7. So the early finish for activity B would be 7 add 4, which is 11. And then this 11 will come to this box here, and 11 add 5 will give us a value of 16. Now, what do you reckon should be the early start for activity C? So mind you, the early start for activity B was day 7 of our project, and there is a lag of 3. So thank you, and that should be 10. So 7 add 3 would give us a 10. So mind you, it depends on the relation. So the relation is connecting the box at the beginning. So we are not doing finish to start. If the arrow was like this with a lag, so it would be 11. It should have been 14 in that case, but that is not the case. So it should be 10 here, and adding 3 is 13. Now, when we manually schedule this type of an activity, E is called merge activity because it is merging two activities. So we have an option here. Either we could use 13, approaching it, or we could use 16. What do you reckon shall we use? So we have 13 or 16. It's a merge activity, and um, the suggestion is 16, and that is the right answer, because if we use 13, we are defining the logic. The logic is telling us that activity D and C must be finished before we begin activity E. So if you put 13 here, it means that you are beginning activity E without having finished activity D, which would be contrary to the logic. So we have to place 16. So from this, we have learned that when we are doing a forward pass, if we come across a merge activity, we have to choose the largest value. So this is a rule of thumb that has to be kept in mind. And the 18 would be the early finish time for the last activity. Now, this what we have done just now is called the forward pass, and it helps us calculate what are the early possible times to start work on our project. That's well and good. Now we have to reverse this project, and we will be doing a backward pass, and which will tell us basically what is the latest time we could begin work on our activity. So basically it reverses. So basically, the early finish of the last activity becomes the a late finish. So this box is called late finish, and this box is called late start. So early finish of last activity becomes the late finish of the last activity, and then we will be doing the reverse process. So previously we were adding, here we will be subtracting. So 18 take away 2 is 16, and then this 16 is carried to the boxes, and then 16 take away 5 is 11. 16 take away. Right, so you know, hit the wrong button, and I will need to, so just hit me. So 16 take away 3 would be 13, and then this box 11 would move here. Now this uh, box over here could be approached from here, which is 11 take away 4. We could either use 7, or approaching from here 13 and take away 3 is 10. So previously we learned that while doing a forward activity, forward pass, we choose the largest, and when we come across sort of a merge situation. In a backward pass, this is reversed. In a backward, if we come across a merge activity, we would choose the smallest, and the logic is reversed. Uh, so we will be using 7 and then 7 take away 5 is 2, and 2 take away 0 will give us 1. Right, so we have learned a few concepts here, how to do early start, early finish, and late start, late finish. The third thing which I want to touch upon is the slack or float. So basically we calculate the slack by using this formula, which is basically late finish minus early finish, which basically means subtracting this box at the bottom, the box at the top from box at the bottom. So 2 take away 2 is 0. It basically means that the slack or float of this activity is 0. Now we will come to float, but basically it means how many days you could delay this activity without delaying the project. So this is basically telling us this project will take 18 days or week, whatever our unit is, to complete. And a float of 0 here means that this activity A should not be delayed. If you delay this activity A, you will not be able to meet. This is a critical activity which must be done at time. So for activity B, 7 take away 7 is 0. And for activity D as well, it's 0. However, for activity C, it is 3, and activity E, it's a 0 float again. So in this particular option, the path which comprises all the activities with a 0 float is referred to as a critical path. So here, E, D, G, E will be the critical path, whereas activity C is a non-critical activity. So we were talking about relations between activities. The other type of relation is start to finish, where successor task cannot finish until the predecessor task starts. For instance, worker can start work on the site only once they have finished the induction training, or you must not start work on the roof until delivery of material has been completed. Operational cannot be finished. Right. This is an example very similar to the previous one, and if you want, you could take a print out from the slides and give it a go. So just to give you an idea, this would be 0 at 2, this will be 2 at 2, 4, and this will be 4 7, and here this is this will be 2 here, 2 at 4, 6. Here there is a bit of a start to finish relation. So this box over here, approaching from 2 at 7 is 9. So we could have an option either to use 7 or 9, and we should be using a 9 at this place, which is normally in this problem. Other than that, 6, 9, and 9, and then F again in early finish of F is a merge activity, so either 10 or approaching from the top will 9 at 3, 12. So we will be choosing the largest value, which is 12. You can do it either manually, or you can take it to schedule in the software of your choice, like Microsoft Project or Primavera, and prepare a manual solution or a computer-based solution. Right. So in the previous example, we did learn and touch upon critical path. Critical path method, it uses a deterministic approach, which suits a project where time duration can be predicted. So we will talk about two different types of situations. One is where we definitely know, for instance, this activity is going to take 7 weeks. But in sometimes we do not know that it's definitely, the contractors give us time brackets. They could say that, well, this activity could take anywhere between 5 weeks to 13 weeks. So for that sort of a situation, we will be using what's called probabilistic scheduling. So here we are taking an example where we definitely know time duration of any activity. CPM was initially set up to address the time cost trade-off dilemmas of project managers, where there is a complex relation between project time to complete and cost to complete. In large complex projects, CPM can be useful to work out the effect of changes. So here is a simple problem given, which you could practice on the problem information, develop an activity and arrow project method. So this is the same notations which we have been using: complete a forward and a backward pass, compute activity start, and identify the critical path. How many days will this project take? So the first thing will be for us to draw a logic diagram. So for instance, this is activity serving sign, and it has got more figures as well. Right, so I guess sound is better. I will drink some water as well. Right. So in this example, we could see that survey of the site is the first activity. It has got no predecessor. The second activity, installing the drainage, depends on activity A. So this follows B follows A. The installation of power lines also depends on completion of activity A. And then we have got excavation of site, which is depending on activity B and C. And the last activity is pouring the foundation, which depends on site excavation. So that is, so using this predecessor relations, we will first of all draw a logic diagram. Once we have done this, this is how our network diagrams look like. Now here you can see the legends. So the box over here indicates the duration of different activities, which is also given here. Then this top box basically tells us early start and early finish. So as we said, we assume that project starts on day 0. So that will be 2 and 2, 7. Now D is a merge activity, so we could either have chosen 5 or 7, and we will be choosing the largest of the two values, and that would give us early finish for activity D as 11, and then this will become early start of activity E, and the early finish for activity E will be 14. And then this becomes the late finish of the last activity. 14 take away 13 is 11, and then 11 take away 4, 7. 7 would be copied here, and then 7 take away 5 is 2, 7 take away 3 is 4, and then serving of site is a merge activity. We could either use 2 or 4, and as I said, we are doing a backward pass using the smallest of the two, so it will be 2 and a 0. So once we have done that, we could start identifying the critical path, which is basically the float. So using the formula, which is late start minus early start, or late finish minus early finish. So basically subtracting the box at the top, so it will be 0 in this case. 2 take away, so subtracting this box on the top, and the box at the bottom will give us 0 here. This will give us a float of 2, float of 0, and a float of 0. So we could see that the path which comprises all the critical activities would be a critical path. So in this case, these activities must be delivered on time. Whereas we have got a float of 2 weeks, which basically means we can delay this activity by up to 2 weeks without having any in the project deadline. So how many paths can you see in this network diagram? And which of these three or of these paths will be the critical path? So we could see a path ABC here, which has a duration of 7 at 1 at 13, 11 weeks. We have got a path DE here, which has a total duration of 7 weeks. And thirdly, we have got a path DFG here, which would have a duration of 8. So which of these three paths are the critical ones? So we can see that this is the largest path, in our network. So mind you, we are not talking about an individual activity, but a path. So we have a path ABC or path DE or DFG, and the path ABC is the longest path, and this longest path is called a critical path as well. So another definition of a critical path is that it is the longest path in your network. And also, if we are asked how long will this project take to deliver, the answer would be 11 weeks. So it also indicates the duration to take a project to complete this project. Uh, so we take another example here. We are asked which one is the critical path, what's the duration of the critical path, and what uh, total number of paths. So if we start from the first question, total number of paths, how many do you reckon? So we have a path here, DH, and we have got another path here, which is DEFG, and thirdly, we have a path here, ABC and G. So we have got three paths here. And what is the duration of the critical path. So to do with that, we have to see what is the duration of each individual path. So if you look at ABCG, it has a duration of 10. If you look at DEFG, 17, and DHI, 11. So of these, we could see that DEG is the critical path, and it has a duration of 17 weeks. So DEFG is your critical path. So if you are managing this project, these activities DEFG are the critical ones which you have to ensure that they get started and delivered on time. If any of these activities get delayed by 1 week, if that's the unit of time which you are considering, that would mean that your project will be delayed by 1 week as well. Right, so and the question here is, how would you define a critical path? Uh, it is the longest path in your network, and a delay in any of the critical path activities will cause the entire project to be delayed. It indicates the duration of your project, and in the previous example, it was 17 weeks to complete your project, and it is the shortest logical time to finish your project. Now, what do you reckon is the significance of critical path method? So it gives you the freedom. Basically, non-critical activities are those which can be delayed. It helps in resource allocation issues. It will help you finish your project fast. It will help you communicate effectively. And in some countries, it is a legal requirement. So in this learning path, there are a few links to the document. So just by clicking on those documents, so first is the legal case between Arab and Hong Kong-based company. You could uh, see the dispute. The action was commenced by Myant against Arab in 2002. Uh, and the decision was the Arab had been negligent in the design and was liable for the consequent damages of that negligence. At the last latest hearing, which took place, Marine were claiming some 38 million pounds. So whenever we have delay claims or dispute, then very often we go back to the critical path and try to determine what was the result, and this subsists of liquidated damages, rectification costs, acceleration, and other time-related costs. So in the previous example, we learned about float or slack. It is basically indicates an amount of time an activity can slip without causing a delay to your overall project deadline. We also learned about these definitions. The early start is the early event time of an activity. If we take an example, I give you a coursework and maybe that's week one of your the semester, and the semester has got 12 weeks, and you get your assignment in week one, and you have a look at the assignment, and you reckon it is a 2 week work for me. So you could start right from the word go in week one, and maybe by week three, you would perhaps be done and dusted. So in this particular example, your early start is week one, and your early finish will be week three, and you will have a float of 9 weeks where you could possibly improve this work. But if you are a late starter, you would leave it to the last minute, and it has to be in that case started by week 10, which will become your late start time. Because if you further delay it, you will miss the deadline, and you could finish. So in that case, your late finished would be. So it gives you a bit of a flexibility to start an activity based either on the early start time or the late start time. Um, Now, the best practice is always to make use of early start times, because that shows that we have got some float. So if things go wrong, but that is not always the case. Sometimes we have to use the late start time, right? So here is one example. Your client had borrowed money for his construction project from an investor at a very high interest rate. Now, which dates will suit the client more? Now, if sometimes we borrow money from the bankers and investors where they charge an interest rate. So let's assume that they're charging an interest rate at 9%. So the money which is tied in our construction project is basically incurring interest. So if we use early start timings, that means we have to incur a lot much more interest. Uh, the other option is we schedule our work on the late start timings, right? That means that your capital investment is locked up for a slightly lesser time than compared, but the drawback is that you have got no float or slack left. So basically, your project is sensitive, and there is a chance that something goes wrong, your project will be delayed, or you could use some sort of a median approach, and maybe a middle of early or late start time to the best time cost curve. Now we will discuss this, but this sort of extreme graph between early and late time is also referred to as a banana curve. And this is also used for planning and controlling the project. So when we are executing the project, we try to stay within this banana curve, and not because right, so we continue our discussion on CPM calculations, looking at some other examples. Here is an example given. You are preparing a project bid requesting City Council funding for a park and ride project. The funding body requires submission of a network plan for the design phase of the project. As part of the bid submission requirements, the Chief Engineer at City Council wants you to develop a project network plan. To meet the funding body requirements, she has provided you with the following time estimates and their dependencies. Draw a project network, clearly identifying activity early. So this is another example, very much based on previous ones, trying to encourage you to do a little bit more practice so that you get comfortable with this concept. So if we look at this and see how this network logic is drawn, so the first activity was A, which was not dependent on any other activities. Then activity B, C, and D, they were dependent on A. So you can see the relation. So using this logic diagram, this network diagram is drawn. Once you have done that, you could start doing your early start calculations, so 0 and 5, and then this 5 is moved to subsequent boxes, and then you add the time duration, which will give you early finish for B as 25, and then activity E is a merge activity. So we have got three options here. We'll be choosing the largest of the three, 35, which will bring us to 115, which will be copied here, and then we have to add And J is a merge activity again. So we will be choosing the largest of the value. So 145 and 155. This way we will complete the forward pass, and then we can do the backward pass in a similar manner. Right, so we move to why is Slack important to the project manager. Slack is important because it represents the degree of flexibility the project manager has in rearranging the work and resources. A project network with several near critical parts of little Slack gives project manager little flexibility in changing resources or rearranging the work. So if your project is based all on critical activities, that is like cast in stone. You can't do anything about it. So Slack is the thing which offers you flexibility so that you could schedule your project. Right. So far we have learned how to draw project networks and do some CPM computations. The next thing is to see how we transfer this information into a bar chart or a Gantt chart. And then, so very often we would see, so this is an output produced from a software indicating the project bar chart. Here you could see on in this column very clearly laid out work breakdown structure where there is a summary task, and within this summary tasks there's various individual tasks. So this is a very good way to have a big picture view of your project through just including the summary task, and within each summary task you could have a minuscule details and a lot much more information. So some other examples from a construction project. And then we can see this work breakdown structure and the visual representation of this work breakdown structure on the right hand side. So we will see how do we create this bar chart. So first of all, we start with the CPM calculations, so 0, 2, 0, 4, and then this 2 will now either we could use 2, putting in activity D, or 4, and as it's a merge activity, we will be choosing the largest. Activity F would be 7, and activity G is a merge activity, and we will be choosing as the largest value, 11. Activity H is a merge activity as well. We could have chosen 7, 9, or 11, and we will choose 11. And so let's assume we want to draw a bar chart based on early start time so that we could have the maximum float. So we could see activity A is from the 0 to 2 of our project, so the work will be done from 0 to 2. Activity B is from 0 to 4. Activity C starts after activity A, and it goes from 2 to 7. Activity G starts after A and B, and it is to 7. And activity E is shown here, and then activity F is starting after activity C, and it's a 2 weeks activity. Activity G is starting after D and E, and it's a 4-week activity. And the last activity is activity H, which is, so we are completing this project, and this bar chart indicates when various subcontractors will turn up on site. Right, so this is how we convert, and mind you, I have used the early start timings here. I could have done it based on the late start timings as well. Now here I have not indicated the float, so to do that I need to complete my uh, network. So I have to have an idea of a Slack. So let's use a different ink curve to differentiate. So this 13, 11, 11, 7, 11, 9, 9. So in the backward pass, we choose the smallest value. That's why I'm choosing 4. And here, right. So here we have completed the backward pass, and now we could identify the float. So the float for activity A is 2, for activity B is 0, 2 here, 0 here, 2. Right, so we can see that for activity A, we have got a float of 2, so we can indicate within our bar chart that there is a float of 2 days existing. B is a critical activity, so it cannot be delayed. Activity C has again got a float of 2, whereas activity D is a critical activity with 0, as you can see here, and E has got a float of 2, and F has got a float of 2, whereas G is critical and H is critical. So this way we can see where we have got a float or a slack within our bar chart. Right, so now you're encouraged to reflect on this bar chart where two different situations are given, before and after. And you can see in a before situation, the project was completing in by about 24-week period. But we have done few changes. The project manager has manipulated a few resources, and now the project manager is delivering this project in 22 in comparison with 24 weeks. Now, saving 2 weeks from a fixed project could mean thousands of pounds or millions of pounds of saving, depending on how big a project is. Now, no additional resources have brought here, and the question is, how did the project manager save 2 weeks from the project? So one thing is quite clear. um, the critical tasks are shown in the dark gray color, whereas non-critical are shown in the light gray color. So to reduce the project uh, duration, you have to reduce the critical path. So uh, only way you could reduce the duration of a project is basically to squeeze your critical path. Now in this bar chart, you can see the resources are overlaid. So for instance, the activity 2 requires 4 bricklayers. Activity 7 requires 4 bricklayers. So here the project manager has seen that these activities 7, 8 and 9 have got a lot of a float here, which is just sitting there. And he has decided to transfer some of the resources from a non-critical activity to a critical activity. So rather than having 4 bricklayers working on a non-critical activity, uh, what he has done is he has diverted 2 bricklayers to a critical activity. So moving 2 resources who were working on activity 7 to activity 2 has resulted in delivery of activity 2 in a shorter duration. So essentially, by diversion of resources from non-critical to critical tasks, uh, the project manager has essentially saved 2 weeks. So two bricklayers moved from here. So likewise for activity 8, which required 4 bricklayers, 2 bricklayers have moved here. So you can see that in a new configuration, there are 6 bricklayers working here and only 2 bricklayers now working in activity 8. Likewise, 2 bricklayers from a non-critical activity 9 have moved to activity 4. As a result, you could see that the benefit is that we have saved 2 weeks, but the drawback is that our project has become many more activities have become critical, right? So if you see the dark gray boxes on the top, and if you compare, you will see the project has become more sensitive. Now, this is a natural thing which happens once you try to squeeze your project becomes a bit more risky, and there's because you're basically eating away all the float. So the chances of project getting delayed do increase. Right, so there are a number of projects which failed to meet their targets. One interesting case study is Holyrood, which is the Scottish Parliament construction where there was a public inquiry and it has got a good discussion on critical path and delay analysis. And other case studies mentioned here. For instance, in Wembley, there was a 253 million pound legal battle over the delays, and this Holyrood inquiry, which relates to Scottish Parliament construction. Now, talking about Scottish Parliament, the initial cost of the project was 50 million pound, and the final delivery cost was 440 million pound, almost more than 8 times over budget. Now, here you can see the Gantt chart of what was planned and the actual delivery. So here the plan was to have schematic designs and the detailed designs completely by around this period, and then there will be production information and detailed designing, and the construction will start from here. But actually, the way this project was delivered, the designing went halfway through the construction phase. So you can see that the design is running parallel to construction. So basically, we are on site, and still the designs are not complete and not clear as to what has to be done. The scope is being changed. As a result, you could see the consequences. So a key message which we could learn is that it is very important to do our thinking before we go on site. So what are the key benefits of CPM scheduling for contractors? Um, the contractors could calculate the project completion date. Using CPM calculations, they could calculate the start or end of a specific activity. They could coordinate among trades and subcontractors and expose and adjust conflicts. It could encourage them to do deep thinking, to understand the logic of the project. It will help predict and calculate the cash flows, improve the work efficiency. It could serve as an effective project control tool. So not only planning it, but also to ensure that we are delivering to what we promised. And if it is not, then introducing different control measures to put the project back on track. We could use CPM to evaluate effect of changes. And in case if things go very wrong, they can prove the delay claims. From the owner's perspective or the clients of the projects, they could use CPM scheduling to get an idea on project's expected finish date. They could ensure the contractors are properly planning for the timely finish. It could help them predict and calculate the cash flow. It could serve as an effective project monitoring tool, evaluate the effects of changes, or also from their perspective as well, they could verify the claim details. Right, so this example is to help you practice how to draw a bar chart or a Gantt chart. And we have done enough, so you would have an idea. You could try it if you want in your free time. So we have learned how do we convert, do the CPM calculations, how do we do the early start, late start, and then convert this information into bar charts, so that we could communicate it with the rest of the team. So a bit of a theory of bar charts. It was originally developed during World War I in the US as a visual aid for planning and controlling shipbuilding projects. Typical format of a Gantt chart consists of a time scale on the top, the activities here, and the duration of the activities start to finish date, so and by indicated by these bar charts. Gantt charts have been proven very popular and is widely acknowledged today as the most effective method of communicating planning information. Very popular tool in construction, and also we are seeing a bit of a push within our industry towards using 4D planning software. So basically, we have got a 3D visual of our construction project, and we link this 3D with the timeline, and this is often referred to as a 4D. And sometimes we bring the cost data into it as well, and often referred to as a 5D. So three layers of design X, Y, and Z, and then integrating it with cost and time. We'll be talking about it in later uh, presentations. There's a most used technique within construction, easier to disseminate information, simple to adjust the program. It does not support the clear definitions of interdependencies. Whereas it's a bit cramped, it's not very good to demonstrate the logic. So the suggestion is that you do your network diagram separately, and then you could transfer it into a bar chart. planning and programming happen simultaneously. Now, some definitions and reviews. I will skip some of the slides, some of the disadvantages. Um we did learn about the network diagrams and the bar charts. So networks and diagrams are good to indicate the sequence. You are encouraged here to reflect on what are the key differences between these two concepts which you so network diagrams, they are good to show you the logic, how different activities are organized. Bar charts, not very well for the logic display. Um, uh, in terms of the complexity, networks can better handle large and complicated projects. You can have the big work package level overview and how the work will be arranged and delivered. In terms of estimation, a network uses mathematical calculations, whereas bar charts use graphical skills to communicate the information to the subcontractors as to when they have to turn up on site and when they have to deliver the work. And in terms of time, bar charts are time scaled, whereas networks are not. Bar charts are considered simpler to prepare and understand. Communication bar charts are easier to understand for those not familiar with CPM. And information bar charts can be loaded with additional information such as cache resources. So use of different scheduling techniques depend on the nature of the software, how complex it is. Very often we see a lot of construction contractors just using very simple graphical schedules. So using very simple tools such as a floor plan, marked up or colored to show the schedule. So for instance, if all the work is painting different rooms within a school, they could just use the floor plan and indicating that the work will be done here in this. So it's a simple scheduling technique that is easier to understand. So the choice of a scheduling tool depends on the nature of a project. If it's a complex project with many different activities, obviously, such a simplistic method will not work. Right. So often we see an argument that there is no need for scheduling. So here, the scenario is your colleague has argued that her construction projects are always changing. It is impossible to keep up with the schedule. There is no need for the schedule in the first place. Give at least 5 reasons to counter her argument highlighting the importance of formal written schedules. So it looks like a very disgruntled construction manager whose schedules are always changing, and she is arguing that there is no need for a formal written schedule. So there are delays, and all the activities are not getting back on time. So what are the reasons to highlight the importance? The very reason that the projects are getting delayed uh, highlight the importance of formal schedules, right? So it's not an opportunity to get away from planning, but rather the planning needs to be taken more seriously. Time reduction is possible through detailed thinking and advanced analysis. So the whole process of developing a logic diagram and the bar charts encourage very detailed thinking and logical understanding, which helps the planning effort. And as it's commonly said, if you plan to fail, you plan to fail to plan, you plan to fail. And then out of order activities could lead to rework due to lack of advanced planning and scheduling between different subcontractors who are involved. Schedule will provide team with goals to work on. No overtime, quality problems, safety violations, litigation. So if the plan fails, it has got a knock-on effect and improve your PODC effort. So it is said that this acronym should be remembered, which indicates planning, organization, direction, and control. And if this project is failing, it is important that there is a strategic level overview of how planning, organization, direction, and control is being managed to put the project back on track. Right. Now, historically, we have seen the schedule being used to put a blame on others. So when there are problems with delays, to settle those claims. So that is not the purpose of the schedule. And how is it possible to override this? Things like we are seeing last planner or collaborative planning, where we have a shared vision of our project. So schedules are not used to put a blame on others that, well, this is because of you, we have been delayed, rather than trying to fix the problem. It could be used to motivate the people. It is seen as a live document and communication on who is doing what, when, and where. A lot of sites will review their schedules almost on a daily basis, in a daily huddles and small meetings with the team. Do not use it as a legal stake to force others into compliance. Right. Now, this reflective question prompts you to think on what are the key skills which are required for scheduling. So things like a knowledge of CPM theory and scheduling concepts is important, knowledge of project management, including project control, knowledge of scheduling computer program, hardware, knowledge of construction industry, such as commercial buildings, transportation. Right. So to back this up, there are links to some additional reading chapters. This one is from a book of called Managerial Approach. So you will click on the link and it will open the relevant learning path. Right. So as I said, we are trying to squeeze two sessions into one. So we will continue our session on cost and resource scheduling. Uh, So I guess you're fine. If you want a break, you can interrupt here for a few minutes. If not, if I don't hear, I will just continue. So am I good to go? Okay. Okay, good. So we will further build on our concepts, and we will now discuss how we could manage our cost and resources based on the concepts reviewed earlier. A few tips: you will learn scheduling by doing and not just by listening or reading. So it's important the skills acquired to help you complete projects to cost, time, and quality targets could be potentially be applied in various types of projects such as residential, manufacturing, commercial, industrial, engineering businesses. So the scheduling skills are not specific to industry. The similar set of tools could be applied across various types of projects which you may be handling in your private and your professional life. The range of scheduling software such as Primavera, Microsoft Project, Astra Project, Sage or 4D modeling software such as Synchro, Navisworks, and the good news is that you do not need to do all these forward paths, backward paths, these calculations. The software does it for you. But the problem is using computers without a fundamental knowledge of scheduling will not be beneficial. You could ask the computer to do resource leveling for you. It will figure it out, but unless you understand, you will not be able to understand, and that would not help your project without it. So why do we need to plan effectively? And this is illustrated by this level of influence diagram. So here you could see two lines. The first line is the ability to impact cost and functional capabilities. So if you look at the project life cycle, starting from prelim design, schematic designs, detailed designs, and then construction documentation phase, when we are at a prelim stage, our ability to impact cost and functional capabilities is maximum because designs are live. We can change the floor plans, layouts. It will only be on a computer screen. It will not cost your project anything. So the suggestion here is that a lot of thinking should be done over here at this stage. Likewise, the graph 2 indicates the cost of design changes. At an early stage of your project, the cost of design changes are minimal because all you're doing is live design. Anything could be changed without having any major impact. But unfortunately, the way we work within our construction, the production team and the contractors who have got a lot of knowledge about production get involved only after the bidding. That's almost halfway in this life cycle. And using value engineering principles, they try to trim the scope of the project to get the project back on track. So we see a lot of uh, thinking taking place quite late in the project life cycle. So we are seeing a lot of movement within our industry to shift this peak slightly earlier using more integrated approaches of working such as design build contracts or integrated project delivery, which would allow us to do a lot much more thinking and reflections a bit early in our life cycle. So we see a lot of examples of bad project management here. For instance, the Wembley Stadium initial cost was 200 million, and the final delivery cost was 767 million. And you saw in the previous slide the legal battle which took place between contractors and clients and the designers. Likewise, High Speed 2 is in news these days. Again, long before spirits have hit the ground to build, Britain's planned 55 billion high-speed train has given the appearance of hurtling out of control. So some issues. And if you pick a Sunday newspaper, you will see a lot of examples. And historically, we see a lot of projects fail to meet their targets. As a result, construction clients are not very happy. So here is a scenario is presented. You are being brought in to rescue a project which is in total chaos. Plans have not got enough details. So these are some problems which we often face within our projects. Site managers do not understand the plans and specifications. Owners keep changing their minds. Subcontractors, they are never showing up at right place and right time and delivering inferior quality work. Suppliers are not delivering material on time. Suppliers are complaining material is not being ordered with the right lead time. So what are could be the potential strategies to uh, rescue the project or to put it back on track? So sort of things which could be done. Previously, we reviewed this acronym PODC. Have a review of your planning, organization, direction, control effort. Take responsibility. So very often it's very easy for management to put a blame on subcontractors. So the viewpoint is that if there is something wrong, it is management responsibility, and they should be. Maybe you could use tools such as root cause analysis or five why analysis, where you keep asking a why question till you get to the bottom of the matter. Or problem-solving approaches ensure job specification and schedule is clearly communicated. So we do encounter a lot of challenges, and using some of the tools available in the toolkit, we could address. Right. So the other prompt question here is what makes management of a construction project different from non-construction projects. Now, construction projects are unique in a way that we often argue that projects are unique and unrepeatable, even because of if it's the same project according to the same design, but you, on different soil conditions or in a different geography, it becomes a project on its own. Construction projects are temporary. Projects are constrained by time, money, and quality. Projects involve many conflicting parties. Many decisions are made based solely on experience. Then there are certain industry characteristics, such as we are an extremely fragmented industry. We are rapidly affected by recessions, very little investments in research and development, and then there is a confidentiality and lack of information sharing. We often operate in a culture of mistrust where there is a tendency to share minimal amount of information, and we are a bit slow to adopt new technologies, and then there we are facing increasing challenges. Now, however, this view that every construction project is unique and unrepeatable, this is now being challenged, and we are being encouraged to have a more manufacturing-based approaches, very much like how IKEA delivers services to its clients. So, for instance, if you go to an IKEA store, you can customize your kitchen or your bedroom wardrobes according to standardized components. So, how you have more factory-based approaches rather than starting with a blank sheet of paper. On this exercise, on the left are different definitions of project management. Project management effort is wider than scheduling, and on the left is the header. So, for instance, defining contracts and choosing a contractor to do the work for the project. This involves procurement. So, this is just to bring to your attention that project management effort is much wider than scheduling. However, scheduling provides an important input into all of this, keeping everybody working towards the same goal, and dealing with changes that could be possibly integration. So you could do this exercise just to create an awareness of what are other dimensions such as risk, quality, scope, management, procurement, communication, time, integration, cost, and human resources. Right. So one key aspect that we focus on in scheduling is time. The time is money, and so here you are encouraged to think what is the cost of interest resulting from a 1 month delay on a £75,000 project versus a £5 million scheme. So if we have uh, um, invested, we have borrowed at a 9% annual interest rate on a 75,000 pound 1 month delay only in terms of interest cost. Where, mind you, we are not taking into account other direct and indirect costs. It's only going to the bankers in terms of increased interest, that is 563. But if we look into a delay in a 5 million pound project, that will be 37,500. So you can see once when there is a scheduled delays, it has got a lot of knock-on effect, and it could easily put the project into a difficult situation. Um, Now, on the other hand, if you talk about good project managers, so a proactive construction manager saved a month on a 10 million pound residential building job, leaving to an additional 1 month of apartment rent for his client because of early handover. So if we could deliver it quickly, there are a lot of fringe benefits. But what is the interest savings in this particular case? So by completing the project 1 month ahead of schedule, only interest savings would be 75,000, and this is on top of the additional uh, rental income which has been generated by the client. So a key message here is that time is money, and it is very important. Now, this very good book by Stephen Covey, Seven Habits of Highly Effective People, and he has suggested to divide our activities into different quadrants. And quadrant one is often referred to as a firefighting quadrant. So here we are trying to handle things which are urgent and also important. So responding to daily queries, daily change orders, requests for information. So some of this will be important, but we are focusing our attention on urgent. Whereas quadrant two, in Kobe's view, are things which are entirely very important. So we are not firefighting, but doing a lot much more strategic thinking here. So what is maybe 1 month look ahead of our project? How are we progressing? What sort of a KPI? So Stephen's view is that effective project managers should be spending more of their time in quadrant two. Now, what we see is people spending almost 70, 80 hours of the week firefighting in quadrant one, and they have not got their processes right. And even though they put in a lot of effort, but with broken processes, they do not get the results, and as a result, they have a burnout. And so his view is that it's very important to think strategically, and similar sort of viewpoints are backed up by other. So, for instance, this study, it's not any scientific stats here. The suggestion is that the project managers should be spending almost half of their time thinking ahead, anticipating what lies ahead, and maybe 25% of the time planning and working to the cost and time targets, and 25% to communicate. But thinking ahead should be a key priority, particularly important with construction. We have to be have a very proactive approach. So would you agree with this statement that best schedule is the one which gives you the quickest and tight timeline? So as we go about scheduling, shall time be the only and sole consideration? Right, so it's right. So time should not be. We need to look into project triangle, or golden triangle, as it is said, cost, quality, and time, or sometimes quadrilaterals, which includes safety dimension as well. So construction is often referred to as a dull, dirty industry. There are five M's which are important when we talk about these M's, referred to as machinery, materials, um, management, manpower, and I think I'm skipping 1 minute. You can look into. So these are all different dimensions that we need to look into. There's a link to a 5T model, which is a little bit, we will come to it. So very often, project management effort involves looking at different dimensions, cost, performance, and time, and finding a suitable compromise. So here are different project management scenarios presented here. You decided to invest in a house. So the project time duration of the project was 4 months. Refurbishment project is running late, kitchen is still not refurbished, and you already have exhausted your allocated budget of 30 grand. You decide to sell the house even though it was not complete. So here you can see you're trying to ensure that you stick to your time targets. And you're trying to not exceed your cost, but in this example, your quality is going down the drain. Now here is an example where a client is keeping on changing his requirements. Project scope was blown out of proportion. You are now meeting the client to discuss the project. So in such a case, it's highly likely that your cost will be very high. Your time will be also going out of proportion because the client not be, and quality is a big question mark, but it may suffer as well. You have performed 30% of the work and already blown 79% of the project budget is gone. Now you go back to the schedule and try to reduce the number of tasks from the project to save money. So here is an example where you are compromising your quality or the specifications which were agreed to ensure that you stick to your uh, cost targets. So when we have to uh, uh, make such trade-off decisions. Uh, The hospital construction project was due on February 2020. You could not manage the deadline. You negotiate a new deadline. So when your time goes out of proportion and then you face a delay, it has a knock-on effect both in your cost and quality. Okay, so the other reflective question is that your friend is extending a house and is asked your advice on use of appropriate scheduling system. What factors would you consider while selecting an appropriate scheduling system? Would you recommend a check sheet or daily to-do list, a bar chart, magnetic boards, or a 4D plans or a 5D plans? So mind you, we have to take into account needs of each individual project. So it would depend on maybe what is the project size. If it's a simplistic house extension, we do not need a very sophisticated 4D software. What is the owner and architect requirements? What is the complexity of the job? What is the technical literacy of the people who will be operating this scheduling system? And the time requirements, what is the critical success factors, and the people, process, and technology dimension. Have we got the right processes and have we got the right technology? So we have to choose a right tool for the job. So just assuming that the most sophisticated scheduling tool is good for each job may be wrong assumption. Sometimes for a simplistic job, simply a bar chart is good enough. But if it's more complex, then we need to. So there are different factors that have to be taken into account. Right. So we did learn about bar charts. We will continue this discussion now to learn about cost-based budgeting, or how do we use bar charts to manage our costs. And this is a concept which we will talk about, which is plan value, or if you are using a software, they use the term budgeted cost of work schedule. We will be coming back to this concept in a later sections, and particularly when we talk about project monitoring and control, a very important concept. It talks about creating a time-phased budget and draw a graph showing a cumulative baseline budget. This graph is also known as a project cost baseline, or also known as plan value or budgeted cost of work schedule. PV is an important tool to determine cost schedule variance as the project is implemented. So we will learn how we will draw uh, uh, PV line. So here in this case, the logic is shown in this network diagram over here, and also you can see the CPM calculations, the forward pass and the backward pass have been done, so we don't need to worry about that. Now this is the cost breakdown. So this is how the payment will be released for different work packages. So for instance, the cost for work package A is 10,000. So it's a 4 weeks task. The total budget is 10, and we would be receiving a payment of 10 grand per week during the activity. Now, activity B we are receiving 8 grants in the first week, and then 4, and then 8, 4, 8. So maybe it could be based on the physical amount of work we are accomplishing on the site, and likewise. So we will be producing a cost-loaded bar chart. So the first activity you can see based on the early start timings is activity A, which is starting from uh, week 0 to week 4. So the budget release is based on this. So we would be receiving 10 grand for activity A during the first 4 weeks. The second activity we will target is activity B, which is also beginning at right at the beginning from 0 to week 5, and the budgetary is 84848. So we will be receiving 84848. Third activity is C, which is beginning after activity A, and it's a 4 weeks activity, and we are receiving 12K per week. So activity C and activity D is taking place after A and B, and it's 5, and the payment release is 62226 from here. And activity E is starting after activity B, and is 8, 8, and 12. And the last activity is activity F, which right. So this is the total cost breakdown will be 18, 14 for week 2, 18 for week 3, 14 for this week, and 20, 26, 22. Right, so we can do a cumulative uh, weekly payment. So by end of week 0, we would have 18. By end of week 2, we would have 18 add 14, 32, and by end of week 3, we would have a cumulative payment release of 50, 64, 84, 110, 132, and we can continue like this. Now, I've got a graph paper here, but I would use these measures to plot a graph. So let's assume this is my graph paper, and I have got 0, 30, 60, 90. So on the vertical axis, I have got the payment. So it's 30,000, 60,000, 90,000. So on the x-axis is, so let's assume this is my starting point. By end of week 1, we are receiving our cumulative spend is 18, so it will be around here. By end of week is 32, maybe here. By end of week 3, it is 50, and end of week 4, it will be 64, and moving on to 84 here, and then 110, right? So this graph which we are drawing here is often referred to as a planned value or a budgeted cost of work schedule. So almost all of the modern day software help you draw this graph. Now this is a very important tool, because once we are delivering a project, we will be monitoring our actual cost spend. So if it is our actual spend, we can immediately see we are overspending. So we have to see why we are overspending. Are we accomplishing more work, or it's a genuine overspend? Or if we are going like this will be a sign of an underspend. So this plan value line provides a critical tool to help us see how our project is progressing. So what are the key advantages of time-based budget baseline, which we just discussed? It gives you an idea about how much work is accomplished against the money you have spent. Without a time-producing cost to match project schedule, it is important to have a reliable information for control purpose. Now we will learn how we could use the cash loaded bar chart to manage our cash flows. So here is an example of a So here in this example, the network diagram is for you and the CPM calculation. And uh, for different work packages, the total value is indicated, the duration in months is indicated, and the monthly release. So as it's activity block W is an activity which takes 2 weeks to complete, and the total value is 45 grand, which means that every month you're going to get half of that, which is 22. Activity B, for instance, is 192 grand, the total budget. So divided by 4, it is basically the monthly release will be 48 grand. So the constraint here is the owners are guaranteeing a finance of this project limited to 110,000 pounds. So you can't exceed this limit. So what we do is we do a time-phased budgeting. So here, in this example, the bar chart has been done and it has been loaded with the costs. So for instance, the activity one, which is W, has a total duration of 2, and every month you are receiving 22.5. So we have indicated 22.5 for activity K. And your total budget is 12, which is indicated here, and also you have got some float here. And activity B, the total budget is 48,000 for 4. So total budget was 192 grand, but you're on a monthly basis you're receiving 48. So what we have done is basically on a weekly basis we have done the total value, and we have used this to plot a resource histogram. Now the constraint which is given in this problem is that the owners are not releasing any more than 110,000. Um, so how you reckon this resource overload problem could be addressed? So here you can see that in month 4 of our project, for instance, we are spending 132, whereas this is breaching the maximum payment agreed by the owners, which is 110. So there's a cost overload here. Month 3 was okay. With month 4, you can see so this is the area which is causing us some headache, right? So we have to explore how best to deal with this. So the first question is, will delaying activity K, so we have got some float here, will making use of this float will help us get back on track. So if we assume we move it from here to here by using this float. But I think that it's not going to make any difference because it is further going to add, and we will have this resource load problem sustaining, right? So we have to see what are other options. Activity B, you can see, is a critical activity. There is no float here with activity. The float is indicated by this line over here. So we cannot do anything about activity B. It has to stay on this line. So the other options are, we can postpone activity P because P has got some float, so we can take it away from here and maybe deliver it slightly later to get the project within agreed limits. Or we can also explore uh, moving activity F uh, to slightly later. So in case if we do F and delay F, it will have a knock-on impact on activity O as well. So we have to explore what works well. So this is obvious that K is not an option because this will further increase. Uh, B is again a critical activity that is not going to solve our problem. So either we could explore delaying activity P or delay activity F. So a potential uh, so so suggested solution is given here. So the decision was taken to delay activity F. So make use of the float, and as a result, we will reduce the resource demand and we will end up with a slightly smoother resource profile. So in this example, we learned how we address the cost constraint problem. So the learning points from this example were that float gives management team the ability to manage different types of resources. From resource management viewpoint, float is much more important than critical activities. With critical activities, management has no choice, whereas float gives management the ability to fine-tune the project and better manage cash flow and resources. Similar sort of a concept. Um, Taking this example, where instead of uh, cost, as was the previous example, we are talking about construction machinery. So here, the D8 caterpillars and their resource requirements are documented here, and we have used this information to plot this resource loaded Gantt chart, and resource requirements are indicated here. Now here we can see that, and we can bring only 10 caterpillars on the site, and there is sort of a resource overload. We requiring 11, 11, and 12. So we have to explore what are the options. Now in this zone we are making use of B, but B is a critical activity, so we can't do anything about it. So either we could explore delaying activity P, which is one option, or the other thing is to delay activity F. And if we do so, O is connected with F, so it will have a knock-on impact on F as well. So here is the solution. So the decision was taken to delay activity F. As a result, you can see we have ended up with a more resources which is within the required limit. So this section we are further building on our discussion. We learn how to do bar charts. We learn how to use it for managing our cost and resources. So very often what we do is we load our bar chart with the resource requirements. So here, for instance, 10, 10 is the resource requirement for each bar chart, and then we produce resource histogram, which is also called resource unit aggregation chart. Now, one thing about the resource histogram is that we do not want to have too many peaks and troughs. So if you are, for instance, talking about workers, that may mean that you are firing a lot of workers in one day. So we would like to have a more smoother resource profile rather than the one with too many peaks and troughs. So some theory about it. Uh, Three main key resources found in construction projects you have to be aware of. Firstly, labor. Secondly, installed equipment, and uninstalled equipment. So this type of resources to deal with. Very often we have to do a resource duration trade-off. So in this example, we are erecting 12 tons of steel with 150 man-hours per ton, and the shift is 10 hours. So we can calculate the man days, which would be 12 times 150 divided by 10. All right, so it will give us how many workers we would require. And then we have got an option. We could bring in more resources. So for instance, if we bring in 10 resources, we will be able to deliver this work in 18 days. But if we bring more resources, possibly 180 by 14, you could possibly deliver it in a much early period. Right, so the next thing is to discuss resource leveling. All leveling techniques delay non-critical activities by using the positive slack to reduce the peak demand, and we fill in the value for the resources. Resource leveling or smoothing involves attempting to even out demands on resources by using the slack or delaying non-critical activities. Right. So let's take this example, and we have a subcontractor. We need to install flooring in two areas. The simple project is broken into activities shown in the following table along with the logic. So this is indicated here. The precedence relationship is shown here, the duration, and the number of workers which are required. So use this information to do our network analysis, and then to produce to augment our bar chart with the resources. Now here you could see this is the project days, and this is the labor requirements and the workers required in each day. So if we produce a resource diagram, in this particular problem, the constraint given is that we cannot have any more than 6 workers. Right, so this is the limit. Now here we can obviously see that this is the problem area where we are bringing in 7 workers. So we have to go back to our schedule and see what could be done about it. So the obvious choice appears to be to delay because there is some float here. So take this and postpone it slightly to get this resource peak back on track. So this is what we have done, and as a result, we have uh, ended up with this sort of a resource histogram. But the other option, which is explored, is possibly to use this flat uh, to have a much more smoother resource profile. So rather than starting here, slightly move it upward, and this will indicate that we get resource profile which is much smoother than the previous one. So here you can see we have got a bit of a trough here, and we don't like these peaks and troughs. So in this, we are starting with slowly, and then we have hired and we are working with consistent number of people, and then slightly. So this is much like a typical S-shaped sort of a situation where the work starts slowly, and then there is a peak in the middle, and towards the end it tends to slow down. So when we talk about resource leveling, the critical activities are cast in stone, so there's nothing much we could do. But those activities that have got some float could be done. So here, in this example, the resource requirements for the early start is shown in this line here, and the resource requirement for the late start timing is shown in the dotted line over here. And we can see here that perhaps the late start timing is providing us with much more smoother resource profile. So there's a bit of a improvement in comparison with the early start timings. So again, this provides us with the flexibility to see what works better. So we don't like such sort of a resource profiles in our project, particularly if this is workers. We do not want to have situation where we are hiring and firing people, or it could be machinery. We don't want to have a situation where we bring in equipment and then um, uh, not use it for a certain period. In an ideal world situation, we would just like to have a smooth line of the resource profile. But this is ideal, this is not possible. So the tendency is to get something closer to the smooth, at least in the middle of a project. We want to have a right. So I think we are getting close to the activity. So I think we will just do remaining slides in the next session.